Hi guys, we're going to have a look at a composite functions question. Isn't that really great? Haha, because they're sometimes very poorly understood. This one's a beauty, so it should help us to really understand how these things work, okay? So what have we got? We've got a function such that t maps to real numbers where f of x is the square root, positive square root of 9 minus x squared, guys. Do you recognise what that is? Because I'm about to tell you in a minute, so think about that. Where t is the implied domain of f, that should be, the implied domain of f. Sorry for the little boo-boo. Let g, on the other hand, where r maps to r, where g of x is x squared plus 2, that's a quadratic, we know that, don't we? We have to find t. We have to find the domain and the range of f and g, and thirdly, we have to state whether or not fog or goff, as I call them, are defined, and we have to justify our answers. Alright, you ready to go? Let's blast off. Now, part A, we have to find what t is, alright? Now, guys, f of x is a semicircle. It is the top half of the circle x squared plus y squared equals 9. Did you recognise that? I hope so, because you should have learnt that one, I think. So if we solve x squared plus y squared equals 9, just to remind you, we get y squared would be 9 minus x squared, and therefore y would be plus or minus the square root of 9 minus x squared, wouldn't it? And if we're talking about the plus bit, we've got the upper half. There's the whole graph. Okay, now watch this, abracadabra. There we go, guys. There it is. That's the upper half, okay? You can see it's a semicircle, so it's very easy for us to deal with the matter of t, capital T, yeah? Because it's from minus 3 to plus 3. It's the domain, yeah? Inclusive, that is. Minus 3 to plus 3 inclusive. Are you happy with that? Very good. There it is again, just to remind us. Now, we've got to go on and do part B now. The domain and the range of both f and g. Alright, for f of x, which is this little beastie, we know that the domain is from minus 3 to plus 3 inclusive. We just worked that out. The range, on the other hand, is from 0 to 3 inclusive, as you can see on the graph. Quite clearly, can't you? Excellent. Now let's deal with g of x now. G of x is a quadratic. It's x squared plus 2, no restrictions on it. So therefore, there it is, guys. And you tell me, what's the domain? Oh, I think I heard you say R. Very good. And what is the range? Terrific. 2 to infinity, including 2, not including infinity, yeah? Alright, so that's very good. We've done that now. Now we've got to deal with the gritty business of fog and goff. Let's do fog first. And then at the end, I'm going to let you do goff. You can do goff, because fog is the more difficult customer, okay? So let's see what we've got here. There it is. Now, fog means f of g of x. So you've got x coming in here. The g turns him into g of x. Then g of x comes beetling out here, goes flying in there to be have the f function applied to it, so it becomes f of g of x. That's the deal, okay? F of g of x is fog. Okay, what I've done here is I've said this is the natural state of affairs for g of x. It normally doesn't have any problem at all, as we've just been saying. The domain is R and the range is 2 to infinity, including the 2, not including the infinity. And for f of x being that semicircle, we know that the domain was from minus 3 to plus 3 inclusive, and the range was 0 to 3 inclusive, alright? Now guys, for a composite function to work, this bit here has to be wholly contained within or coincide with this bit here, and as you can see, it doesn't. This is trying to go all the way to plus infinity. This thing stops at plus 3. So we've got a problem. We have a problem here. The range of g is not wholly contained within the domain of f. No, no, no. So therefore, what can you conclude? You conclude that fog is not defined. That's what you conclude. It's not defined, guys. Okay? So if we were to restrict the domain so that we do have a function f or fog star, if you like, which is defined, we would restrict g of x so that the range of g is compatible with the domain of f. That's what we're trying to do. So I will go on and show you how to do that, and although the question didn't specifically ask that, we'll go ahead and do it just to show you how to do this stuff, okay? Because you really need to get very good at it, all right? Now, here is the range of G. From 2 black dot, that means including the 2, up to infinity. This is the domain of F, between -3 to +3 inclusive. Now you can see that they're not compatible because this black line here is not wholly contained within the red line here. So it is a problem, isn't it? You can see quite clearly that it is. Let's keep going. The overlapping section is compatible with the range of G and the domain of F, guys. That's the bit that we're going to have to restrict ourselves to in order to make this thing work, okay? Because it's the only part of the black line that fits into the criterion of the red line, if you know what I'm saying, yeah? We need to restrict dom of G so that the range is from 2 to 3 inclusive. This is what we need to do. Can you see that? Can you see it? So let's work these things out. What would be the x values required to make that happen? So if I put x squared plus 2 equals 2 and solve it for x, guys, I get x squared is 0 and therefore x is 0. Okay, that's part of the picture. Now I'm going to do the same thing at the other end of the spectrum here. If x squared plus 2 equals 3, let's see what happens there. What would x be? X squared would be 1 and therefore x would be plus or minus 1. How interesting. Let's draw a graph of that. I always love to draw a picture because it makes everything clear. There's the graph of the parabola we're talking about, y equals x squared plus 2. There is the line y equals 3, and there is the line y equals 2. So the bit of the graph that we want is the bit in here. That bit in there between 2 and 3. Let me make it clearer for you. That bit there, which I've gone over in heavy red pen. That's the bit we want. Now, what we've got to do now is work out what x values give rise to those y values that we actually want. I think you can see it, can't you? I think you can. So therefore, if the range of G is going to go from 2 to 3 inclusive, then x has got to be, roll the drums, from -1 to +1 inclusive, doesn't it? So therefore, we say, guys, that fog modified, or fog star as I've called it, looks like this. You see, we've got 2 to 3 here, and we've got 2 to 3 there, inclusive, right? So it's now compatible, no problem. But what we've got to do now is got to work back to here and work out what goes here. Well, we've already done that. In fact, it's over here, there, right? We've done that. That will give us the domain of fog star, as I'm calling it, okay? Because the domain of fog star is this end of the assembly line. And, of course, if you wanted to work out the range, which we'll do anyway, just for the sake of it, we will work out the range that comes out this end if 2 to 3 goes in to f of x, if you know what I'm saying. Let's just do it, okay? So we work backwards as we have done for g of x. We found that x had to go from -1 to +1 inclusive. That's what we did, wasn't it? Yeah? Now let's work forwards, okay? We're working forwards for f of x, and we can say that when x is 2, that is the input to f of x is 2, just at this end here, what would be the output result, okay? F of x corresponding to when x is 2 would be the square root of 9 minus 2 squared, which would get you the square root of 9 minus 4, which would be root 5, yeah? Now let's do the same thing when x is 3. We know that in that case, f of x would be the square root of 9 minus 3 squared, which would actually be 0. So now we've got the range sorted, guys. The picture is now complete, and we have the following scenario. Ooh, look at that. So you see, look, in order to make these compatible, we had to restrict that to -1 to +1, whereas its normal state of affairs would have been R. And if we restrict this one, because remember this thing has a diode of -3 to +3 x's, but we had to restrict it from 2 to 3, then the result coming out this end here is from 0 to root 5. See how it goes? So therefore, dom of fog star is -1 to +1 inclusive, and ran, or range of fog star, is from 0 to root 5. My goodness. Now, what else is there to do? Oh, I thought I'd work out the actual function for you, okay? What is the function? it's f of g of x star, so therefore it's going to be square root of 9 minus not x squared, but g of x squared. So it's going to be that. There it is, guys. That is our function, and of course we know that the restricted domain of that function is this one here. Okay, that's how it works. I didn't work that out because I couldn't be bothered. It looked too ugly, okay? So I just left it like that. Now, it's your turn now. It's your turn. Goff. Over to you, guys. I'll give you a little hint. Goff is a lot easier because Goff is defined. But why don't you go through the same exercise as I did? Work out the domain, or first of all you work out the compatibility issues in the middle. If you're satisfied that they're all right, and I think they are, then go from there, work out, just confirm what the domain is, which will be the domain of the left-hand end, and work out what the range is. You work it out and come up with what you think the function for Goff is and compare that with somebody that you know that's already having a go at it, and I'll leave you to it.